So what will we learn? Let's start with two questions that we'd like to try and answer here. Number one, how do we construct graphical displays to show the relationship between two categorical variables? And number two, how do we then use that graphical display to determine if there is an association between those two categorical variables? So we're going to start with an example that you should be familiar with from the previous video, and that's looking at age group versus educational attainment. And so we have this table, and on the table, represented across the top, are three different age groups. And then on the left, we have four different educational attainment levels. Now this table is what's called a two-way table because it shows us the two categorical variables here. Now here's what we'd like to try and do. We'd like to try and make a side-by-side bar graph, a segmented bar graph, and a mosaic plot, and then use those graphical displays to determine if there's an association between age group and educational attainment. So before we make any displays, let's talk about how we can calculate some percents here. So here is the original data, and we're going to start by finding the totals for each one of the columns. So in each column, we have an age group represented, and we now have totals for all three of those columns. Next, we're going to find the educational attainment level within each age group. So let's start with the 25 to 34-year-olds. And within that age group, we'd like to know what percent of the 25 to 34-year-olds were in each one of the four educational attainment levels. And so each one of these four calculations, you'll notice, is going to be divided by that column total, 45,212. So let's take those 4% and add those into our table. And so that is the distribution of educational attainment level for the 25 to 34-year-olds. Now we need to do the same thing for the next age group, that is the 35 to 54-year-olds. And you'll notice that in all four calculations here, we are dividing by the column total, 93,506. And so we've added those percents into our table. And then we need to do the same thing for the last age group, 55 years or older, noticing that when we're dividing here, we're dividing by that column total once again. So now that we have these percents, we can create what's called a side-by-side bar graph. So once again, here are all of the percents that we just calculated, and we're going to use those now to create a side-by-side bar graph. Now, just to explain what you see here, the 25 to 34-year-olds, which you see represented in the red box here, are represented in the red box in the side-by-side bar graph, where there are four bars representing the 4% that you see in the table. Now we do the same thing for the next age group, 35 to 54-year-olds, and the final age group, 55 years and older. So now that we have our side-by-side bar graph, we can use that to create what's called a segmented bar graph. So let me start with what we already have, which is the side-by-side bar graph. And we're going to now turn that into the segmented bar graph, which looks like this. Now let me give a little explanation as to how we came up with that. If we look at the 25 to 34-year-olds, there are four different bars there representing the four educational attainment levels. And all we've done is taken those four bars and stacked them on top of each other in order to create the segmented bar graph. So you'll notice the dark blue bar, which is the smallest bar here, is also the smallest bar over here. The light blue bar, which is the tallest one over here, is also the tallest one here. And of course, you're going to get up to 100% here in your segmented bar graph. Now let's go ahead and do the same thing for the next age group, 35 to 54-year-olds, and the final age group, 55 years and older. So now we can use our segmented bar graph to create what's called a mosaic plot. So let's start with what we already have here, which is the segmented bar graph. And I want to point out something that is actually missing in this graph, and that is the size of each one of the three age groups. And the reason that's missing is because on the y-axis, we have the relative frequency, or the percent. And somehow it might be nice to be able to represent that these age groups have different group sizes, where this group is much, much larger than the other two. And so the solution here is to use what's called a mosaic plot. So you'll notice that a mosaic plot is really a segmented bar graph, but the width of the bars is dependent on the size of the group. So you'll notice that the 25 to 34-year-olds, which have the smallest group, is going to have the bar with the smallest width. Whereas the next group, 35 to 54, much wider bar, and then an even bigger bar for 55 years and older. So now let's see if we can get to answer the question about whether age and educational attainment are related. So using the segmented bar graph here, the question that we want to ask ourselves is, if we know what age group a person belongs to, would that help us to predict their educational attainment level? For example, if I knew that somebody was 25 to 34 years old, according to this graph, I would see that they are much less likely to have no high school diploma and probably more likely to have a high school diploma here, which means that knowing a person's age group does help us to predict their educational attainment level. So what that's telling us is that because the distribution of education attainment is not the same for each age group, we now know that these two variables are associated. So what should we take away from this video? Well, let's go back to the two questions from the beginning. Number one, how do we construct graphical displays to show the relationship between two categorical variables? And we decided we have some choices here. We can make a side-by-side bar graph. Then we could stack all of those bars on top of each other to make a segmented bar graph. And then we can vary the widths of those bars using a mosaic plot. And then question two, how do we use graphical displays to determine if there's an association between two categorical variables? And we decided that if those distributions in the segmented bar graph are not the same for each group, then there is an association between those two variables. This is Luke Wilcox signing off. Thank you all for joining me, and I hope to see you in the next video.